mic and proceed this technical session. Santosh sir.
Thank you. I first of all request all the delegates to kindly settle down. We are already late and there are 3 speakers before lunch in this session. Dr. Manoranjan Kar, IIT Patna, Professor Ramanand Rai ji from Institute of Science, BHU, Professor Mohammad Lokman Chaudhary ji from IIT Patna. I will request all the speakers to kindly come here on the dais. Manoranjan Kar sir, Professor Ramanand Rai sir, and Professor Lokman Chaudhary, IIT Patna. I will very humbly request all the speakers. You have been allotted a time of half an hour for your talk, but we are already late and this is already 1. So I will request you to kindly complete your talk in 20 minutes if possible, and 10 minutes time will be for discussion so that you may complete your entire work in half an hour so that the participants can join lunch not on time, a little late. So first of all, I will be requesting Dr. Manoranjan Karji from IIT Patna. Dr. Kar is Associate Professor in the Department of Physics at IIT Patna. He is an accomplished researcher in nanomaterials. His field of research covers nanocomposites, polymer ceramic composites, the magnetocaloric effect, alloys, the electrocaloric effect, energy materials, and the chemistry and physics of materials. Dr. Kar has over 200 international publications, 2 patents, and several prestigious awards, including the DIE Young Scientist Award, DST Young Scientist Award, and the IAPT Best Teacher Award. Dr. Kar has guided 2 ACRB National Postdoctoral Fellow, numerous PhD scholars, MTech and MSc students. He has presented at 60 conferences, given more than 80 invited speeches, and worked on 10 projects. He also continues to make a substantial contribution to academic leadership, research and teaching at IIT Patna. And to the best of my knowledge, one of his research scholars is sitting here, Dr. Ajit Kumar. He is assistant professor at our college. And I can just praise you that you have given a good essay to us. Thank you, sir. I welcome you and I very humbly request you to kindly present your talk.
Thank you very much for giving this opportunity, and this very hectic schedule right now because our basically midsem is coming next week, so we have to be very busy. But still, I thought that okay, I will come because my student is here. He was telling that sir, you have to come, and especially Santosh sir is here, and always I love to meet him and visit Patna. So I have kept and. Unfortunately, I did not keep the topic, the student work, but it is very interesting. And that student is not that he is in Commerce College. I want to tell the story. When he called me yesterday evening, very important, please listen me, that he is the integral part of my research journey, because whatever I have contributed to the research world, and that is his work. We started a thought and I told that Right now I am working on it and I will take to a height. Now that has been recognized and I am not, please don't take it very easily. It is totally entire different thought and we have established and we are working on the mathematical formulation. Already I have done it, but experimentally we have claimed something and we have theoretical formulation also. It is not simulation, nothing, it is that. So that is the news that if anybody wants to do it or to check it, I cannot go through because my topic is not that. It is entirely different. So please drop me a mail and definitely I will tell. And we took around 7 years to get the recognition in international market because people has to first understand and look it, and now we are getting lots of response and so many means how to do it and what is that, and we are getting it. So sometime I can share somewhere later. But today I have kept the topic that because it is a just combination of the physics, chemistry, and that work was entirely physics, and it is a chemistry, biology, and everybody. But the topic I have kept, it is not different from them, and just I will give only few messages because time is very short. And by the way, the work I have means what I am going to show, and entire work who has done, and I cannot go out without appreciating, and he is also with me, Dr. T.P.S. And just after 2 months, he will be visiting to a different country. Just he completed PhD last month. So he's going for the postdoc to the abroad. So that work I'm going to share with you that what exactly we have done. And I was entirely expertise on magnetism, but there is nothing magnetism on this, and we have done something, and that's what I give the credit to him and also his junior. He's from here only. He was doing the PhD in Taiwan, but he left and come. Why I am telling this, and technical is fine, but it is very important that being in also in nearby, we are doing lots of things. And if anybody wants, they can come and look at it, and never we say no. So if you are thinking something that we can do with us, please come forward and let us know. So thank you very much for giving me this opportunity. Let me tell that this nano generator, it is not new. This word is not new, but it is entirely this thing. And before going to that, so these are my students, and it is a long list, and they're doing here and there, and almost lots of students are around the BR. It's okay, you can look at it today, everything is in your fingerprint. So comes back. So the fundamental for my young students and everybody, if you look at the entire formulation, very simple. It is not very big or very complicated. It is only we have assumed one particle electron, and we have given its mass, charge, and spin. Then the distribution function tells exactly what is the material. That's all. Story ends there. Entire science and entire universe is lying on that, and our reference is the electron. If, please listen carefully, I am going to give you statement. If anybody is trying to explain what is an electron, either the person who is listening is doing the mistake, or who is trying to explain is doing the mistake. Because electron you cannot explain. Electron we have formulated, we have assumed. So what you have assumed, you cannot explain. I have assumed. Okay? So it has been calibrated from a chemistry experiment, but I don't know that how many of you know from a chemistry experiment, that is the electrolysis. It has been calibrated, its charge, mass, then we have given the spin later in the other experiments, but entirely the electron concept has come from the electrolysis, and it has been calibrated, because nothing you can tell that okay this is this and I have to calibrate and tell like centimeter and all. So that is the entire story. But the electron behavior. So now what I can do with it? I have given things I will not go. If you ask me that what is proton and all, and the story does not end there, I can explain. But reference will be the electron. But electron I cannot explain exactly what is that, and I can give some example. This is the experiment, this is the experiment, this is this, because I have calibrated and I have assumed. But electron is complementary to that. Anyway, so that's what entire story lies there. And now, I'll tell that what we do with it. Okay, energy solution comes to the mind, and how can you do it? So as a basic researcher and sitting in India in some small part, what we can do. And another thing that I'm going to give you the definition of the nanocomposite, and you may think that okay, I will Google it and I will learn. Please believe me, it will be very difficult to learn. and we do the misleading nano-composite, and sometimes we say the composite and nano-composite, but they are totally different. Nano-composite, it is not that if I have taken a nanomaterial and mixed it, it is nano-composite, it is not. Even if it is a composite, but if I take a 50% of the one nanomaterial, 50% of another, and I mix it. So this is the problem, that when we do the research, we stop. And we try that, okay, nano, and I heard from somewhere and I'll put it is not. And we have lost our textbook, that's what it happens. So nano composite is totally different from the nano, means your nanomaterial as well as your composite. And nanomaterials, that you have to have a matrix where you have to put the filler. And filler percentage should be less than 10%, should be. And because I will not go to the physics theory, population theory will come to the picture, but I give the just information. If you want, you can extend. It should be less than 10%, and it should be less than 10%, and it should be size should be in nanometer scale. And I did not tell that what is that. It is a big story, the nanomaterial, and we do the mistake by doing this. I'm not going there, but you just remember that what I say, it should be less than 10 nanometer, and it should be means in the nanometer size, whatever you have the definition, and in the physics. I'll not take that. So that is the information I want to give. And if you go to the properties, and this is the very sorry. So this is, I want to tell that is a very simple equation. Nothing is there. If you look at that, and if the two particles or atoms are there, it is the building block when they overlap, and what will happen, that your factor will become the zero. So that means you can tell that single particle, when they separate, it happens. The same concept is applied in the nanomaterials, nano-composite and everywhere, and explain the properties of the material. So just I will give you the idea. So I'm not going to there, what are there. So just you look at it. This is our picture only. And what it is happened, that you have a matrix, red color, black dots you are putting the nanomaterials, both can be nanoscale, no problem. But what happened, that when you will keep on increasing 50-50, so no more, they will be, pillars will be interact each other. So they will be no more, they will be independent. So if you look at it, so for example here, you look at that, the size is nano, but they are not nano, because the same material has come and joined together. So together it is not coming to the nano, so they will not give you the nano property. So that's what I say, that 10%, I will give you example, you will understand easily. We have all the ornaments. It is 91.2. Never we thought that why it is the 91.2. So it is just a alloy. So you cannot go beyond that, because you will lose the properties of the gold. And it will not be the composite, and which I look for the high strength, and it should not be harmful, and this thing and gold property will be there. Forget about that. You are using the cement. Same concept in the cement. If you look at its properties, by the way, I know all this because I had a consultancy on the cement, and I know its a composition. They are also 4 to 5%. We add it, and still you are using for your house building and all. They are also only 4 to 5% we add on the steel, because to increase the strength. So all the theory lies there. So when you say the nano-composite, please don't mislead, and it is the alloy or anything, it should be 10%, and size has to be nanometer. So if you look at the property and you look at this, so your property at the nano-composite, it will increase, then in the composite it will be some other story, and in the nano-composite this will be different story. So by looking to this theory, this is the just basic to my friends, and this nano-composite, we just pick up the polymer and try to make some nano-composite which can be a generator, energy generator, and that's what we are working. Then we look at our previous research like that, which can be the best nano generator. Then we pick up a very good material, barium, strontium, titanium oxide. And what is our beauty? That the student is sitting here, we thought that, and we have to put a conducting filler along with a dielectric filler so that it can enhance the energy value. So that's all. So research cannot be, I cannot say that, oh, I am thinking something different. So you have to look at that around what is going on. Then you have to put your thought with that basic knowledge, whatever you have gathered, and look at it. Then we see that if I put a put a conducting filler. So I'll just go directly. I'm not coming to this because time is not there. So I'll just share our research work, what we did it. And sorry. If you look at this polymer, this is just a dielectric polymer. We pick up and we have to create it the polar molecule. So for the polar, and I have to arrange it like this. This is ceramic particle. So that was the concept. What we did, we just put a stimulator of the conducting carbon film. So what happened, and it became the great story that it shows the very high voltage and the current. So then we started preparing the material and follow the procedure, scientific procedure, how you can have a systematic study. Then we look at that, what it is happening, modeling, then what we get, that it give you the very good. And this is the model that we thought in our mind that what is exactly happening. If you look at that, these are the polymer, then you have this BSTO nanoparticle, then you see, nothing is happening there. These are the model that we thought that inside maybe it is like that, it is happening. Nobody has seen that atomic and molecule. Nobody can show you that it can, only they can show the behavior. A very interesting story of the observable and your non-observable. So with that story, what we did, and I've given the reference or wherever it is published, you can look at it, that chemical engineering journal. So you can look at that, and this model, it worked out very nicely. Then we did all these, these are the devices we produce in a lab to test it, that what it is happening. And you'll be surprised, you don't require so much infrastructure to test it. Only 50, 60,000 in nodes and one DSO to see that what is the voltage is generated, and so that so that is that you have to go for the all the characterization and all XID and other things. As you know that in this short period it is very difficult to exactly go that how to characterize and all. So then after doing this and all these measurement, just I will show you. So okay, so just I was going to show that how if you tap it, the voltage is generated. So the story starts from there, how you can convert it and how can you use it for the use. So you can look at that, and there are the videos what I don't know, it is not running. These are the videos, means that how, means you have to again calibrate and you have to look at that if you are the pressure, giving the pressure. So these are the voltage is generated, and this voltage is not very small. It's a very high voltage. So in the order of 180, 150 voltage you can generate, and along with the current. So if you look at it, then you know that you have to publish that, you have to make it properly. So these are the voltage. If you look at that, it is the 40 voltage with a particular pressure you can generate. Nothing is there, just to give the pressure, then you can generate up to the 40 volt. So here you can look at that, means with the small pressure you can have the different kinds of the voltage. But the question is that, sir, what is the beauty on it? So what you are saying, that means what the title I have given, that you have a mechanical pressure, you don't need any battery, anything. Nothing you require, you give the pressure and it can happen. And you'll be surprised to know this kind of the devices are already used in the robot. But what is the difficulty the people are getting? They are using the hard piezoelectric material to get the voltage, but they are the self-powered. Hard, and it is available in the market in the, if you can buy from the Amazon and etc. Just type it and you can get it. But the problem is that they are the hard piezoelectric or the hard material. So that's what the researcher are trying that if I can have a flexible, I can put anywhere. So I don't know if photo is there or not. And if you look at that, we just, as you know, that you have to compare with the other voltages, and you can look at that the voltage, and again it depends upon that current, even if in the microampere current it gives. So very interesting. If you go to the school project also nowadays, the students are also doing some project on this because it is available in the market that I told that hard. But it is what is our research goal, that we have to bring the flexible nanocomposite materials which can be utilized in place of the hard, so that it can be extended its use. And if you go to the robotics, and it is almost in the robotics application, everywhere it is used, in the eye and everywhere it is used. So these are the reference that I showed you. Then finally what to do, you have to generate the power. So you have to do the electrical circuit, collect that power, so that you can use for the mobile charging and other things in the application. So research extend there, and we develop lots of different kits, remote to remote in, so that these activities we are doing. So if anybody interested, and they can look at it, that what we can do together. But the story does not like there, and if I told in the beginning, we had used the PVDF and put the BSTO, there is another dielectric material, then as a chemistry to look at that, we put again multiple carbon nanotube or the stimulator as a conducting filler. But then we thought that can we replace it with a single material, because if you put the three materials when you are mixing, and something will be somewhere and someone will be somewhere. But if I put the only one and nanocomposite, I can get it. So that's what we look at that which material can be best. And the first time we just pick up alloy. People are not trying, and because they think that magnetic alloys, they will be agglomerated. So with the lots of difficulty, we could disperse it properly, the magnetic alloy, but only one material, not the multiple material, so that it will be easy to process. Then we took the manganese aluminum, which is knocking the door, that to be used in the technology, the next magnetic material. So we just pick up, and we were working long back. So I thought that we can take that material because it is conducting as well as very anisotropic, highly anisotropic. So that we try to do it, and it is also the similar way we did it. So I'm not going to there, and these are the results, that what voltage is coming and current is coming, that we did it. So, and this is that by leg, putting in the chest. So everywhere we tested, voltage is generated. Okay, so then we calibrate that how you can use it. Even if you can make a pressure sensor, just you put it here, and device is not, you don't require that to make it in a very highly sophisticated lab, and we have generated and we have tested. I don't know if this figure is there, and you can look at that. These are this figure you can look, and he is sitting there, he just put it and tested that voltage is coming or not from your breathing. And interestingly, the voltage is sensing because of only small pressure from your heart. So these are the possibilities that as a researcher you can do, and where you can do it. And this is the paper where we have shown. So I'll be coming to the end. I think I've passed the message that exactly what I want to say. So as you know that in short period I can tell exactly what is that. But if anybody is interested, and you can drop the mail and I can give, or you can refer our paper and it is written very nicely, you can understand. So these are the take-home messages for this talk, that a low-cost, lead-free, flexible and multifunctional piezoelectric nanogenerator based on relaxer ferroelectric perovskite materials for energy harvesting applications and sensor for robotic applications, and tertiary PVDF based polymer that I told that it can be used in the robotics, and also the single alloys which can produce the lots of things. So I would like to say that when you have the independent thought, and you will be happy that sometimes the output comes and 4 years back, and we started thinking something that to put it. So just 2 days before, and we got a message that it is in the leading publisher in the IOP. So we struggled to publish a paper in the IOP, but we got a certificate that, and it is the most cited paper among the 1% to be published in entire IOP. So such kind of things you get when independently you thought. This is the message. So my request is that it is not that I can follow something, but independently thought something and what I can contribute. If I get the chance, and sometimes also I will share, or he can share that exactly how it is very simple, but it is different from the others. Nothing is there, no violation of the scientific grammar with the scientific grammar, but it is different from the others. And that is nothing but in the composite also, but minority composite. And thank you very much for giving the time. But if you need any more information, and definitely I will be happy to pass. Thank you very much.
First of all, I express my sincere gratitude to Dr. Kar because he has completed his talk in exactly 20 minutes. And as far as I know him, he is not only a very good researcher and a very good teacher, he is a very, very good human being. So now I invite questions, if any questions are there from the audience. Your questions are respectfully invited. Is there any question or everything is clear? Yes, sir, please. एक माइक है क्या?
Sir, I can repeat it.
I think I can speak from here and everybody can hear. एक छोटा सा इसमें ये है कि you said कि 10% से ज़्यादा नहीं होना चाहिए. Is this a sacrosanct number? You got it from somewhere or there is some research based on this? That is the first point. एक और छोटा सा जो आपने बताया कि प्रेशर भी अगर हम डालें तो हमारा वोल्टेज जनरेट होगा. तो एक ये तो इन जनरल माइंड में आता है एक यूजुअल प्रैक्टिस है, एक यूजुअल प्रिंसिपल है. I couldn't get what was different in your research. They are too small.
So first question is that this 10% where it is coming, nothing, and I did not get the time, beautifully I could tell, and we have not formulated anything without any observation or the calibration. And I could tell very interestingly, just I'm giving the example to understand it, why I write the delta, why I write the delta, why I write the D. Delta, you will be surprised to know, everything has been calibrated with the length scale. We start from the zero, from the nucleus, beautiful science. If you read it, and you will be, your science knowledge will be open in a different way. Everything has been calibrated, and even if our electromagnetic radiation in the length scale, I give you the hints. Just you go back and look at the wavelength, you will be find very interesting story that material in the atomic scale, whatever it happens, the electronic transition, all the characteristic wavelength, if you take, what it will happen, you will find that that is the wavelength we have fixed for the X-ray. We have given the name with that length scale. So if you go beyond that, and when you will go to your beyond below nuclear, then you go to the subatomic particle, your cosmic ray, everything, all the wavelength will become in that length scale. So with this note and what I am saying, that Sir's question, it comes from the percolation theory. We call it the percolation theory, or I just showed you a block diagram. I will go back and I will tell you that, because I am a physicist and without any formulation I cannot believe anything. So that's what, because I could not speak properly. Just a minute. Sorry. Right. Yes. So this is the point. What I am saying that, you look at that, if you have a plate, you are putting something on the top, what will happen? That is the surface energy very high, quantum mechanical, again very beautiful. So what happens that it will disturb in the round. So that disturbance will be change the property of that plate. Very simple. Okay, so now question is that how many dots you can put on this plate so that the individual disturbance can be observed. So that is the percolation, it is called. That is the percolation. That beyond that, what will happen? If I put the more than that, so the disturbance will be overlap each other. So the property will not change. That's what this 10% it comes. Again, this 10% it comes from the percolation theory, and if you look at that, it is the simulation and everything is existing. It is not I am telling that something. So this is the from the percolation it comes. I hope I could make you the sense. And once again I tell, so if you have a plate, so it has a property, now you want to change it, So what happens? You have to put the dots. If you put one dot, so the surface will interact and they will disturb the around. So now you put another dot and which will not disturb that disturbance. If it disturb, that means it is not the nanocomposite. So that's what you have to put it in this way. So this you can do. So this demonstrates. This you can do, and here you see that they are overlapping. Okay, they are overlapping each other. That means they lost the original changing of the property by putting one filler. But here you see they are independent. What about the disturbance? And I will add. It will follow some law. So without means if they overlap, they will not follow any physical law because they will overlap each other. So sir, could I answer the question? So that it comes from there, and calculation I'm not going to the equation and all. Please, if you have any doubt, you can look at it. Sir, the next question, just you asked that means when you are putting it in the natural. So already I told that what is the beauty on the research we are doing. I told that piezoelectric material will give the voltage. This is the general concept, and I told that it is existing in the market, and unfortunately the technological material is PJT. Now no material is existing in the material which can give you the piezoelectric voltage and can be used technologically. I can have thousands of the material in the demonstration, but in the market only one. If you look at the magnetic, whatever we are using, only 4 materials are existing in technologically. Similarly, piezoelectric, only PJT is used, but PJT lead is very toxic, and some of the countries they have banned from the research. So we are looking at the alternative material, and also another property is that flexible property. That's why we are changing its parameter so that we can achieve the material which can be technologically viable. So that's why the basic research lies always there. When you go to the engineering research, believe me, nobody can pick up my material right now and do some engineering design. Only the basic researcher can do, and it will take some more time that to bring it that technological, because technological parameter is not only what I showed you. They have the other parameters to satisfy. Harsh condition, temperature, strength, and all the parameters. But as a physicist, and I have just characterized the electronic properties. So I hope, sir, I answered your question.
Thank you, Dr. Kar. And I request Dr. Hans Kumar to kindly felicitate our resource person, Dr. Manoranjan Kar. Our next speaker of this technical session is Professor Ramanand Rai ji. Professor Ramanand Rai is Professor of Chemistry at Institute of Science, Banaras Hindu University. With over 25 years of research and teaching experience, he has made remarkable contributions in the field of synthesis and physiochemical characterization of binary organic materials, synthesis, crystal growth and characterization of organic, inorganic and binary organic nonlinear electro-optic materials and fluorescence materials. Professor Rai has published more than 80 research papers in reputed international journals, including Journal of American Chemical Society and Materials Research Society, Journal of Crystal Growth, Thermochem Acta, Fluid Phase Equilibria, RSC Advances, etc. Professor Rai has guided more than a dozen PhD scholars and delivered several invited talks worldwide. He is also actively engaged in academic leadership, editorial responsibilities, and major scientific projects funded by national agencies like DST, DRDO, and DAE. He will be delivering his talk on the topic Forecast of Phase Diagram Green Synthesis of Complex for the detection of chromium 6+ ions. I was knowing the limitation of Dr. Manoranjan Kar to speak Hindi, but I can very humbly request Professor Ramanand Rai ji, if possible, you can kindly communicate in Hindi or in mixed language, but not exactly in English. So if you are comfortable, you may please, sir.
Thank you very much for your nice introduction and good afternoon to all of you. Professor Kar is leaving but he has solved my problem many extent. उन्होंने मेरी समस्या का बहुत समाधान कर दिया। क्योंकि हिंदी में बोलना, हिंदी मेरी मातृभाषा है, ये तो मेरे लिए बहुत बड़ी अपॉर्चुनिटी मिल गई। मैं ऑर्गेनाइजर को इस टॉपिक पर रिसेंट एडवांसमेंट बेसिक अप्लाइड साइंस और उनको धन्यवाद दूंगा, उनके कोवर्कर को धन्यवाद दूंगा, इंक्लूडिंग प्रिंसिपल एंड ऑल हूएवर हैज इन्वॉल्व टू मेक इट पॉसिबल। इन वन लाइन आई वांट टू से कि सबको मेरा हृदय से धन्यवाद कि मैं आप जैसे ऑडियंस को इंटरेक्ट करने के लिए थोड़ा सा समय पाया। और जैसा सर अभी लड़ाई चल रही थी कि 10% होना चाहिए, मैं आपको एक ऐसी विधा बताऊंगा कि जो थोड़ा डालेंगे, थोड़ा और डालेंगे, थोड़ा और डालेंगे, तो एक हॉरोस्कोप का नाम सुना है ना, अंगूठी पहनते हैं, हॉरोस्कोप इससे इंटरेक्ट करेगा, उससे इंटरेक्ट करेगा। तो मेरा एक टूल्स है दैट इज कॉल्ड एज इस्टेब्लिशमेंट ऑफ फेज डायग्राम। जब हम फेज डायग्राम बनाते हैं तो मटेरियल प्रॉपर्टी का पूरा हॉरोस्कोप है, वो पूरी उसकी हिस्ट्री बता देता है कि कैसा इसका नेचर होगा। एग्जाम्पल के तौर पे देखें तो किसी भी चीज़ को हम तब तक किसी में मिला सकते हैं जब तक वो सह सकता है। जब उसके सहने की शक्ति खत्म हो जाएगी, सर आपका आदेश है कि हिंदी में बोलना है, बीइंग उत्तर प्रदेश के हम हैं तो बहुत अच्छी बात है। अगर आपको आपत्ति होगी तो स्विच ऑन कर देंगे। सो इट्स अ वेरी गुड प्रॉब्लम एंड नेचुरल प्रॉब्लम टू। फॉर एग्जाम्पल गांव में लोग कहते हैं अरे जब से ही आयोडाइज वाला नमकवा खाए लगली तब से तो ब्लड प्रेशर बढ़ गया। वेरी सिंपल, नो रिसर्च हैज डन कि आफ्टर पुटिंग इन सोडियम क्लोराइड द आयोडीन वेयर इट इज गोइंग। आयोडीन के जब डालते हैं तो सोडियम क्लोराइड का एक स्ट्रक्चर होता है FCC, उसके एटम जगह जगह बैठे होते हैं। जब इसको डालेंगे तो उसके स्ट्रक्चर पे क्या कर रहा है, जैसे सर ने बताया कि वो दूसरे से इंटरेक्ट करेगा, उससे इंटरेक्ट करेगा। यस, वो सही है, इंटरेक्ट करता है। उसकी लिमिट क्या है? तो 10% जो उन्होंने कहा वो साइंटिफिकली नहीं कहा, क्योंकि वो उसको उन्होंने ऑप्टिमाइज नहीं किया है। ये लिमिट मटेरियल टू मटेरियल बदलती है। किसी में 2% होगा, किसी में 5% होगा, किसी में 15-20% भी हो जाता है। दैट इज इन साइंस टर्म कॉल्ड एज सॉलिड सॉल्यूशन। कि जैसे हम शुगर को वाटर में मिलाते हैं तो घुलता जाता है एक पर्टिकुलर टेम्परेचर पे, एक लिमिट के बाद घुलता नहीं है, तो उसको हम सॉल्यूशन नहीं कहेंगे। इसी तरह से ये नेचर है। आज हमने यही डिसाइड किया था कि छोटी छोटी चीज़ों को ले करके हम कैसे आगे बढ़ें, क्योंकि हमारे पास इंफ्रास्ट्रक्चर इतना नहीं है मटीरियल सिंथेसिस, और ये वर्ल्ड वाइड प्रॉब्लम है कि कैसे नेचर को भी मेंटेन करें। हाउ आई कैन मेंटेन द नेचर विदाउट पोल्यूटिंग इट, दैट इज द अगेन प्रॉब्लम। सो व्हाट आई डिसाइडेड टू स्पीक ओवर हियर। सो हियर आई वुड लाइक टू से, ये हमारे भारत रत्न पंडित मदन मोहन मालवीय जी हैं जिन्होंने एचयू को इस्टेब्लिश किया। आप सब लोग अवगत हैं। हम सभी भी विश्वविद्यालय के लोग बड़े आभारी हैं यह अवसर पाने के लिए, और ये हमारी यूनिवर्सिटी का लोगो है। आपका कॉन्फ्रेंस ये अवसर दे रहा है कि जहां हम बता सकें फोरकास्ट ऑफ द फेज डायग्राम। फेज डायग्राम स्टडी कैसे फोरकास्ट करता है मटेरियल सिंथेसिस के लिए। नेक्स्ट प्रॉब्लम का पार्ट है वो है ग्रीन सिंथेसिस ऑफ कॉम्प्लेक्स। Complex is a particular technique, but green synthesis, that is important. How to synthesize the material without using the solvents and pollutants, which can save our nature and we too. And then materials application is also has to be there. So synthesized material, fortunately, is very sensitive for chromium 6 आयन। ये क्रोमियम 6 आयन बहुत ही टॉक्सिक होता है, वाटर में होता है, और इसका कैसे ट्रेस करें, इसका सेंसर कैसे बनाया जा सकता है, इसके लिए थोड़ा सा डिमॉन्स्ट्रेशन विथ हेल्प ऑफ अदर ग्रुप, बट वी हैव डन इट। इससे भी बढ़िया इसकी बात ये है कि ये उस सॉल्यूशन में जिनमें और भी बाईवैलेंट मेटल और जो पानी में मौजूद होते हैं, लेड है, कैल्शियम है, कैडमियम है, उनकी प्रेजेंस में भी ये क्रोमियम को ट्रेस कर देगा। ये इसकी ब्यूटी है। इस काम को मैं आज यहाँ बताने के लिए आपको डिसाइड किया था। ओके, आते रहेंगे। तो पहला पार्ट मैं बताना चाहूँगा ग्रीन सिंथेसिस, जिसमें कोई सॉल्वेंट हमने यूज़ नहीं किया, वो है सॉलिड स्टेट सिंथेसिस। सॉलिड स्टेट सिंथेसिस में दोनों मटेरियल को मैंने डिफरेंट रेशियो, सर का जो बेसिक प्रॉब्लम था कि 10% 5%, डिफरेंट रेशियो में कवरिंग इंटायर रेंज ऑफ कंपोजिशन, दोनों का रेशियो 1%, 2%, 50%, 70%, पूरा हम उसको स्कैन करते हैं, मिला करके सिंथेसाइज करने के लिए सॉलिड स्टेट सिंथेसिस करते हैं। देयर आर टू टूल्स, आइदर वी हैव टू मेल्ट टुगेदर दोज मटेरियल एंड होमोजेनाइज इट, otherwise you just grind it. If they are very efficient in reacting together, then that is also will be yielded to the product. Here खोल दीजिए, कोई बात नहीं। सो कुछ अच्छा होता है तो कुछ खराब हो जाता है, बैलेंस करता है नेचर। हमारे लिए टॉपिक मिल गया कि इसका क्या उपयोग है, तो मेरी पीपीटी ही मुझे परेशान कर दी। वो बैलेंस करता है, लेकिन मैं आपको प्रॉमिस करता हूँ कुछ कम नहीं, पूरा बताएंगे। तो दोनों को मिला करके हम मेल्ट करते हैं, होमोजेनाइज करते हैं, फिर उसको आइडेंटिफाई करते हैं विथ हेल्प ऑफ मेल्टिंग टेम्परेचर, कि जैसे एक कंपाउंड प्योर है, उसका मेल्टिंग टेम्परेचर कुछ है, उसमें दूसरा डालने के बाद उसका मेल्टिंग टेम्परेचर घट जाता है ड्यू टू इंटरेक्शन एक्सेट्रा, वॉट एवर ही एक्सप्लेन, सम एक्सटेंट ही हैज एक्सप्लेन। एंड देन see not only that, in a particular ratio, I mean composition, that can give you a new compound which is going to have the entirely different nature to that of parent. हमारे कहने का मतलब बहुत साफ है, आपकी भाषा में समझा सकें तो ऑक्सीजन है जो जलता है और हाइड्रोजन है जो जलाता है। बिल्कुल क्लियर है ना? एक जलता है, जलाता है, लेकिन दोनों को अगर एक रेशियो में मिला दें तो बुझा देता है। दैट इज कॉल्ड एज H2O। अगर कंपोजिशन मेरा बिगड़ गया, कहते हैं कि जाने दीजिए कंपोजिशन नहीं लेंगे, दूसरा हो गया, दैट इज H2O2, हाइड्रोजन पराक्साइड। बहुत अच्छा, सो थोड़ा बहुत समझ में आएगा आपको जरूर। ये कार्बनिक हो जाता है, इसका कुछ दूसरा उपयोग है। बट लुक एट द फैक्ट, वेयर इज द आर्ट? आर्ट इज द रेशियो। Okay, so best of this example I have many, but it is clear that how ratio is going to participate. So when we establish the phase diagram, we came to know what will be the behavior of this material, and of course to find out those material we have to go ahead. उनको जानने के लिए हम कैरेक्टराइजेशन करते हैं इसका क्या क्या बिहेवियर है। So I don't know why it has happened. Anyway, अब हम एक बार स्टडी कर लिए कि ये पूरा इंटायर रेंज में ये कंपोजिशन हमारे अच्छे हैं। 3-4 डायग्राम मैंने लिया था। किसी किसी में मैकेनिकल मिक्सचर बनाता है, लेकिन मैकेनिकल मिक्सचर मीन्स थर्ड कंपाउंड का फॉर्मेशन नहीं होगा। जैसे आयरन और सैंड को मिलाते जाइए, दोनों का आइडेंटिटी रहेगा, लेकिन कुछ बन जाता है। दैट इज सिंपल। दूसरे तरह का फेज डायग्राम शो करता है बेस्ड ऑन द पैरेंट नेचर कि एक थर्ड कंपाउंड बना देता है जो दोनों में इंटरेक्शन होकर के जैसे आपका H2O बन गया था। जब हम पाते हैं कि इंटायरली डिफरेंट नेचर होता है, ये हमें फेज डायग्राम से पता चल जाता है और हम उसे करेक्टराइज करते हैं। अब सवाल ये है कि रोल ऑफ कंपोजिशन कैसे देखेंगे, ये इसके लिए हमको बहुत ही क्लियर एक थोड़ा थोड़ा बढ़ा के कंपोजिशन देखना पड़ता है। और आई कैन टेल यू वर्बली बिकॉज नॉट वर्किंग कि एक ऐसा डायग्राम मैंने बनाया है अपने ही लैब में कि जिसमें 4 न्यू कंपाउंड बने हैं, 1 2 नहीं 4, केवल 2 लेकर के 4, और चारों नए हैं। उसके लिए DSC, पाउडर XRD, इवन सिंगल क्रिस्टल ग्रो कर एटम कैसे बैठते हैं, ये प्रूव किया गया कि चारों डिफरेंट हैं, उनके स्वभाव भी डिफरेंट है, उनकी प्रॉपर्टी भी डिफरेंट है। तो दैट इज फर्स्ट पार्ट ऑफ माय टॉक कि हाउ फेज डायग्राम कैन टेल लाइक ए हॉरोस्कोप अबाउट द मटेरियल्स। नेक्स्ट कम्स हाउ वी कैन कम आउट टू कैरेक्टराइज दिस वन। तो उसके लिए बहुत सारे टूल्स हैं कि किन किन के बीच इंटरेक्शन हो रहा है। हम NMR करते हैं, IR करते हैं, और मटेरियल प्रॉपर्टी देखने के लिए पाउडर XRD करते हैं, जो कि हमें पता है कि पाउडर XRD नॉट ओनली कैन टेल अबाउट द क्रिस्टलिटी, इट कैन आल्सो टेल द फॉर्मेशन ऑफ न्यू कंपाउंड। फॉर एग्जांपल कि A और B के XRD में अगर इंडिविजुअल पीक जो मैंने असाइन कर लिया 2 थीटा पर, सर हिंदी में ही हम, और जब मिला के देखते हैं तो हमको ये पता लगता है कि कुछ 2 थीटा वैल्यू पर नई पीक मिल गई है अपार्ट फ्रॉम दी चेंज इन देयर इंटेंसिटी। इंटेंसिटी डिपेंड्स अपॉन वेरी पैरामीटर, बट अपीयरेंस ऑफ न्यू पीक डेफिनेटली टेल्ट अबाउट द फॉर्मेशन ऑफ न्यू कंपाउंड। तो वहाँ से हमें प्रेडिक्शन मिलता है, तब हम उसको और आगे बढ़ाते हैं, क्योंकि किसी काम को आगे बढ़ाने के लिए तभी बढ़ाना उचित होता है जब उसका कुछ भविष्य दिखाई दे। तो आगे बढ़ाने में उसका सिंगल क्रिस्टल XRD ग्रो करना चाहते हैं। ये मिश्री आप खाते हैं ना, जो बाजार की है प्योर फार्म में, तो किसी भी चीज़ का जब क्रिस्टल ग्रो करेंगे तो अगर वो कलर्ड नहीं है, बहुत ट्रांसपेरेंट होता, बहुत अच्छा दिखता है। इवन रिंग जो हम लोग पहनते हैं, जितना ही ट्रांसपेरेंट पत्थर होगा उसका कास्ट उतना ज़्यादा होता है, क्योंकि उसमें डिफेक्ट नहीं है। तो हम लोग सिंगल क्रिस्टल से कहा ही जाता है सिंगल क्रिस्टल ग्रो करना। सिंगल क्रिस्टल हमें ये बता देता है कि जो पेरेंट कंपाउंड के एटम आपने लिया है, कार्बन, हाइड्रोजन, नाइट्रोजन, वो कैसे बैठ रहे हैं, उनके बीच में क्या क्या दूरी है, कैसे है। ऑल दोज थिंग्स आर वेरी क्लियर। आई एम एक्सट्रीमली सॉरी, हम आपका समय तो नहीं बर्बाद कर रहे हैं, क्योंकि हमारी ड्यूटी खुल नहीं पाए। हमें एक ओरल क्लास ही हो पा रहा है। थैंक यू। सो हम उसमें देखते हैं कि एक कैसे इसमें एटॉमिक अरेंजमेंट है, और जो फंक्शनल ग्रुप है जिनमें इंटरेक्शन हो, जैसे हम सब लोग बैठे हैं, लेकिन यहाँ कुछ 2 लोग ऐसे हैं विभिन्न जगहों से आए हैं कि वो चाहते हैं कि मैं सीट बदल के उनके यहाँ जाके थोड़ा इंटरेक्शन करता है, कुछ बात करता है। दैट इज कॉल्ड एज इंटरेक्शन, म्यूचुअल इंटरेक्शन बिटवीन 2 पर्सन। तो एटम में भी वह स्वभाव है, जैसा उन्होंने बताया कि जहाँ डाल देते हैं अगल बगल को इंटरेक्ट करता है। यस करता है, किस एक्सटेंट तक करता है, बिल्कुल नहीं करता, ऐसा भी होता है कि बिल्कुल नहीं करेगा। वो सब फेज डायग्राम बता चुका है आगे। तो हम उसकी एटॉमिक पैकिंग निकाल लेते हैं। और थर्ड पार्ट ये है कि अब तो मैंने हॉरोस्कोप उसने इंडिकेट किया कि हाँ नया कंपाउंड बना कि नहीं, बिल्कुल सॉलिड स्टेट सिंथेसिस से बनाया, जिसमें एक भी सॉल्वेंट नहीं यूज हुआ। हमने नेचर को बचाया, अपने आप को बचाया, और जो प्रॉब्लम है वर्ल्ड वाइड उससे भी बच गया। अब सवाल ये है कि जो बनाया उसकी प्रॉपर्टी क्या है। उसके लिए बेस्ड ऑन दी whatever characterization I have, that will indicate and predict that you can go in this direction. So for this we got that it is going to be pure nature and it is going to be fluorescent materials. I mean with a particular wavelength, if I am going to excite it, then it will flourish. So that was enough to proceed with. तो हम लोगों ने देखा कि ये इसका एब्जॉर्प्शन वेवलेंथ है। एब्जॉर्प्शन जैसा प्रोफेसर बता रहे थे कि वेवलेंथ डिपेंड करता है। तो पहले हम लोग यूवी विजिबल लगा करके NIR से पता कर ली कि व्हाट आर द रिक्वायर्ड वेवलेंथ व्हिच दिस मटेरियल विल एब्जॉर्ब टू गेट एक्साइट होने के बाद फ्लोरेसेंस इंटेंसिटी वगैरह निकाला। तो ये लगा कि इसका हम उपयोग कर सकते हैं एज ए सेंसर। लेट अस सी। देन IIT Professor Manoj helped me in this. He was having a good setup. Then he put a lot of material, particularly bivalent material, trivalent, including chromium, which is a very toxic, and somehow it is important to test in the water, either the Ganga water or the industry nearby water or ground water, इसमें कितना chromium है। तो systematically he studied and he found that this is the material. It can not only identify the chromium and its extent, chromium को identify करना और कितना क्रोमियम है ये आइडेंटिफाई करना, इसके साथ एक और अच्छी बात मिली क्या कि वो अगर दूसरे बाईवैलेंट मेटल आयन भी हैं, जैसे उसमें कैल्शियम भी होगा, लेड भी होगा, उसके प्रेजेंस में कैसा व्यवहार करता है। तो इसका इफिशियंसी मिला। सो दैट पार्ट ऑफ द पेपर वी कुड पब्लिश एंड वी गॉट इजीली पब्लिश्ड व्हाइल कमिंग ऑन द वे। प्रोफेसर संतोष सर वाज काइंड इनफ टू ब्रिंग अस। तो सर बता रहे थे कि पेड जर्नल अनपेड जर्नल में कैसे क्या होता है। तो मैंने उसको अच्छे जर्नल में भेजा। उन्होंने कहा कि आजकल जर्नल वालों का एक आपको जानना भी चाहिए ड्रामा है, वो सिस्टर जर्नल रखे हैं जहाँ पैसा मिल सकता तो कहते हैं इसमें भेज दीजिए। तो इसके साथ भी कुछ ऐसा हुआ। तो जब चला गया वो, तो पब्लिश होने के लिए एक्सेप्ट हो गया, रिव्यू हो गया। तो बोले हमको 2400 बीइंग इंडिया, अदरवाइज 5000 चार्ज। हमने कहा हम रिसर्च किसी तरह कर दी, हम आपको पैसा देंगे, उसको लौटाइए। स्ट्रेट फॉरवर्ड, दैट लेटर आई कैन शो यू। नो आई डोंट हैव मनी, समहाउ आई कुड फिनिश द रिसर्च, वेयर इज द मनी टू गिव यू पब्लिकेशन, आई हैव नेवर पेड। तो उनके लिए भी समस्या हुई कि भाई इस काम को तुम्हें एक्सेप्ट कर लिया हूँ, रिव्यू भी कर लिया, कुछ हद तक काम भी ठीक है, नहीं तो लेते ही नहीं, कौन पूछ रहा, उनके रिश्तेदार तो हैं नहीं। तो उन्होंने कहा कि यस, दिस टाइम ओनली वी कैन पब्लिश योर वर्क, बट रिमेंबर दैट दिस इज द पेड जर्नल। उन्होंने कहा इट इज़ वेल नोटेड एंड इन फ्यूचर आई मे नॉट अप्रोच यू। ऐसा ही नहीं तो अप्रोच क्यों करेंगे। तो पेड जर्नल नॉट पेड जर्नल व्हाट एवर डिस्कशन वाज गोइंग ऑन, ये तो हम लोगों का पार्ट है एक लाइफ का। तो खैर एनीवे इट गॉट पब्लिश। एंड जस्ट टू ऐड ऑन द प्रीवियस लेक्चर लिटिल बिट, व्हाट वाज द इलेक्ट्रो ऑप्टिक मटेरियल सर वाज टॉकिंग, सी इन नेचर। बिल्ली को आप 3 तल्ला 4 तल्ला से कूदा देते हैं, उसके फ्रैक्चर नहीं होते हैं, होता है क्या? नहीं होता है, बिकॉज हिज बोन इज इलेक्ट्रो ऑप्टिक मटीरियल प्रॉपर्टी, पीजो इलेक्ट्रिक। लेकिन हम उसको जान नहीं पाए। जो इंटरेस्टेड हैं, इवन प्रोफेसर कर में हैव ए लिटरेचर रिव्यू, प्रोफेसर KVR वर्मा, he has exploited a lot of fish, sea fish, which cell are electro-optic and piezoelectric. Piezoelectric मटेरियल का गुण होता है जब उसे आप स्ट्रेन देंगे और जब वो स्ट्रेन से थोड़ा तनाव में आता है, जब वो तनाव को रिलीज करता है, रिलैक्स होता है, तो वोल्टेज देता है। दैट इज कॉल्ड एज पीजोइलेक्ट्रिक। कम से कम साधारण भाषा में तो वो बिल्ली के पैर में भी है। तमाम सारी ऐसी मछलियां हैं जिनके 2-3-4 का मैंने देखा है, उनके सेल जो है वो पीजोइलेक्ट्रिक मटेरियल है। और ये बहुत कॉमन हो गया है। बच्चों का जूता, वो दौड़ते हैं तो लाइट जलती है, उसमें उसी तरह का मटेरियल लगा हुआ है कि जब वो पैर रखेंगे और इसको हार्वेस्ट कर रही है, कंट्री भी चाह रही है कि ब्रिज पे जब गाड़ी जाती है तो वाइब्रेट करता है। हाउ वी कैन कन्वर्ट दिस मैकेनिकल टू दी इलेक्ट्रिकल। तो अभी देखिए पैनल लगा है, कुछ दिन बाद शायद वो भी आ जाएगा कि इसमें ऐसे चार्ज होगा। कुछ हमारी हाइब्रिड कार में भी इसका उपयोग हो रहा है। तो मैं आपको बहुत डिस्टर्ब किया, कुछ सिस्टमेटिक ढंग से दिखा पाता वो दिखा नहीं सका, लेकिन मुझे खुशी है कि मेरे टॉक का 3 पार्ट इम्पॉर्टेंट था। हाउ वी कैन प्रोसीड इन ए सिंपल वे, जो छोटी छोटी लेबोरेटरी में भी पॉसिबल है, और वो छोटा नहीं है, उसको आपके ऊपर डिपेंड करता है कितना ऊपर ले जा सकते हैं। तो आप मटेरियल प्रॉपर्टी को जानना है। अभी मैंने थोड़ा देर पहले जिनको थ्रस्ट एरिया की बात करके गए सर, तो वो लोग थ्रस्ट एरिया भी ले लें कि सोडियम क्लोराइड को इन्वेस्टिगेट करना चाहिए कि आयोडीन का क्या इफेक्ट है। ओके, दैट इज द सोशल कंट्रीब्यूशन इफ समवन कैन डू इट। तो ये फेज डायग्राम सब बताता है कि ये कैसे हो सकता है। चलिए छोड़ दीजिए। So, sir, this is the, I mean, what I try to tell you. Once you are got phase diagram, और वहाँ पे बहुत अच्छा है, जैसे उन्होंने कहा कि इंट्रैक्शन करेगा। मेरे पास कुछ ऐसे भी डायग्राम हैं कि वेरी लिटिल अमाउंट 0.02 मोल फ्रैक्शन, जो उसको अच्छे से जान रहे अच्छे से जानेंगे, कहने का मतलब बिल्कुल नहीं के बराबर, उतना ही टॉलरेट करते हैं। उसके बाद दोनों इमिसिबल हो जाते हैं, दोनों लिक्विड होने के बाद इमिसिबल नहीं करते हैं, जैसे आप तेल और पानी को मिला देते हैं। ठीक है, तो वो 2% या 0.2% तक ही टॉलरेट किया। टॉलरेट करने के लिए एक और तरीके से हम समझ सकते हैं कि जैसे बड़े लेटस से, हाँ हिंदी में सर ने कहा तो मटर तो सभी लोगों ने देखा है, एक डब्बे में मटर रखे हैं, उसमें सरसों डालेंगे तो क्या करेगा, जहाँ जहाँ जगह वहाँ जाके अकोमोडेट कर जाएगा। दैट इज कॉल्ड एज इन लैटिस इज गेटिंग अकोमोडेटेड। तो जब तक लैटिस में जाकर को छुप सकता है तो इंट्रैक्शन भी रोल करेगा, लेकिन जब उससे एक्सीड होता है तो स्ट्रक्चर भी बदलना चाहता है, तब तो उसको डिस्टर्ब करेगा कि नहीं हटो हमें लेना आ जाएगा, राइट। तो दैट इज कॉल्ड एज डिस्ट्रक्शन ऑफ द लैटिस पैरामीटर। Then only new compound will form. If it is going and getting accommodated inside the material, no possibility for the new compound. Okay, so this all something was there. So starting from synthesis, characterization, and how it can work worthwhile to examine the chromium 6 plus ion in the water, whether it is groundwater, tap water, or let us say Ganga river, or nearby the industry. So that can work. So thank you all very much. Once again, I am very much sorry for inconvenience.
थैंक यू वेरी मच सर। और सबसे पहले मैं माफ़ी चाहता हूं जो टेक्निकल ग्लिचेज आई, जिसके कारण आपका पीपीटी चल नहीं पाया। इसके बावजूद आपने अपने पूरे टॉक्स को बहुत ही सजीवता के साथ डिलीवर किया और NEP 2020 के साथ एलाइन करते हुए हम लोग पूरे विज्ञान को अपनी मातृभाषा में बोल और समझ पाए, एक बड़ी बात रही। ये संयोग था कि प्रयोग था, मुझे पता नहीं, लेकिन जो 3 टॉक्स मुझे दिख रहे हैं, मनोरंजन कर जी का टॉक, आपका टॉक और जो आगे होने वाला है इनके पांडे सर का टॉक, वो तीनों शायद इन लाइन हैं और कहीं ना कहीं सेंसर टेक्नोलॉजी से मिला हुआ और किस तरह से सिंथेसिस कर सकते हैं। और जो सवाल उठाए गए थे नरेंद्र पांडे सर के द्वारा ऑप्टिमाइजेशन की बात मनोरंजन कर जी के टॉक में, वो अपने आप में एक बहुत वाइटल इशू होता है इस तरह के सिंथेसिस में। और अभी अभी सर मैंने एक पेपर कम्युनिकेट किया है, लेकिन मैं उम्मीद कर रहा हूँ कि मुझे भी सजेशन आ जाएगा ओपन एक्सेस में डालने का। तो उसमें मेन जो थीम है उसमें यही है कि प्रोसेस पैरामीटर जो होता है वो सेंसिटिवली कंट्रोल करता है मटेरियल इवोल्यूशन को। तो सेम मटेरियल को, सब कुछ सेम है, कंपोजिशन सेम है, सब कुछ सेम है, लेकिन अगर प्रोसेस पैरामीटर्स अलग अलग हैं तो उसके हिसाब से भी उनकी सॉल्युबिलिटी अलग अलग आ सकती है। और जैसा कि सर ने बिल्कुल सही कहा कि शायद उन्होंने अभी ऑप्टिमाइजेशन किया नहीं है, तो समराइजेशन तो हम लोग बाद में करेंगे। एंड कोई अगर सवाल है तो आप सर से कर लें। हाँ,
वेरी गुड। इसीलिए कहा जाता है ना कि ओरल तो ओरल होगा भाई, लिखित तो लिखित है, दोनों में फर्क होता है। बहुत ही सुंदर इन्होंने क्वेश्चन पूछा है कि ये डिटेक्शन लिमिट 2 मिलीमोल से लेके 40 मिलीमोल तक के डिटेक्ट करेगा, बट यहाँ भी उसकी सीमाएं हैं। एग्जैक्टली क्वांटिटेटिव अगर हम देखना चाहेंगे तो क्वालिटेटिवली वो डिटेक्ट कर सकता है, क्वांटिटेटिवली कि रियल कितना क्रोमियम है, देन लिमिट रिड्यूस टू 2 to 10 मिलीमोल। इट्स अ वेरी गुड क्वेश्चन, आई अप्रिशिएट।
एनी अदर क्वेश्चन?
सर का एक था कि कंडीशन बदलने में मटेरियल बदल जाता है। हम आपको एक उदाहरण इसका देना चाहेंगे। वही कार्बन तो है जो लगता है तो धुलते हम परेशान हो जाते हैं, वही कार्बन है जब खूब प्रेशर में और अच्छा कंडीशन में डाला जाता है तो डायमंड बन जाता है। हम तो चाह के भी नहीं खरीद पाते, वो डायमंड कार्बन ही है। और थोड़ा सा कहीं मिस्टेक से कुछ बनना भी चाहा और थोड़ी कंडीशन बढ़िया नहीं मिली तो ग्रेफाइट बन जाता है, जो 1-2 रुपए की पेंसिल में बिक जाता है। उसका बहुत रोल है, दैट आल्सो आई हैव आइडिया।
तो मैं सर को बहुत बहुत धन्यवाद देना चाहता हूँ टीपीएस कॉलेज परिवार की ओर से। वैसे तो मैं देख रहा हूँ कि हमारा कॉलेज ऑफ कॉमर्स, आर्ट्स एंड साइंस परिवार डोमिनेट कर रहा है। आपको मैं अपने परिवार में शामिल मानता हूँ। 12-13 लोग तो बैठे दिख रहे हैं मुझे। थैंक यू वेरी मच सर। और मैं निवेदन करता हूँ कि सर को फेलिसिटेट किया जाए। Our next speaker of this technical session is Professor Mohammad Lokman Chaudhary ji, who is presently Professor of Chemistry at IIT Patna. He has obtained his MSc and PhD degree in Chemistry from Indian Institute of Technology, Guwahati, under the mentorship of Professor A.T. Khan. And he has worked also in Royal Society as postdoctoral fellow at the University of Manchester, UK, where he worked on the total synthesis of marine natural products and explored SMI2 mediated radical transformation. He leads a dynamic research group that focuses on green and sustainable synthetic methodologies. His current research interests include visible light mediated organic transformations, multi-component reactions, catalysis, and CH activation. Professor Chaudhary has published over 75 research papers in reputed international journals, and his H index is 36, reflecting his impactful contribution to the field. One of his review articles published in Organic and Amp Molecular Chemistry in 2020 was cited in the scientific background on the Nobel Prize in Chemistry 2021. He also received a letter of appreciation from the Royal Society of Chemistry for having his work ranked among the top 5% of highly cited publications from Indian institutions. So he will be delivering his talk on reactions with consents, new frontiers in green synthesis. I respectfully invite Professor Lokman Chaudhary ji to kindly deliver his talk. And I don't know how comfortable you are in Hindi, but if possible, you can please.
Thank you, sir, for such a nice introduction. First of all, I would like to thank the organizing team, T.P.S. College, most importantly, Dr. Balati. Although at this moment it is very difficult because as you know, that from Saturday onwards our mid-semester examinations, so I was having busy schedule, but anyway I cannot say no that whenever I get a call from any college from nearby Patna, because I always try to meet and interact with all the faculty members, research scholars, so that we can share our chemistry and we can also learn from them. That is a very important platform, and I always appreciate this type of platform whenever it is going on in any college or universities. I always try to participate there. Okay, so the timing is not good because any lecture just before lunch or after lunch, always it is in your mind that okay, you are hungry or you are full stomach. So the timing is not good. But anyway, I will try to make my content as much as possible so that you can go through it. So in this, because the organizer informed me that if you can talk about the green chemistry, which is one of the very important area right now, because as we have already discussed that whenever you want to make any materials, whether it is in material science, whether it is in any chemical synthesis, it is very important to think about the product we are making, the way we are making, and also need to think about once the product is formed, what is the lifetime of the molecule or what is the lifetime of the product, and where it is going and how it is going to hamper our environment. So therefore, green chemistry plays a very important role. So in this presentation, I am going to talk about the concept of sustainability and the green chemistry, and how can we make process greener. And then finally, I'll talk about some of the work what right now we are doing in our institute at IIT Patna. So all of you know that whenever we talk about the development, most important thing is the sustainable development. And this sustainable development concept came around 1987 in United Nations. They came up with the idea that development should be sustainable. Because whenever we talk about any development, that means it should meet our needs without compromising the ability of future generations. That means whenever we think about today's need, whether that is going to be sustainable in the future also for our next generation. So then, whenever we talk about this development or your sustainable development, there are three fractions. One is called your economic sustainability, another is environmental sustainability, and the last one is the social sustainability. So we know that for any sustainable development, you need to have these three different sustainability. So understand what is called economic sustainability is in terms of money, in terms of investment. So I am more focused on this environmental sustainability because that is what is directly linked with our green chemistry. So green chemistry is basically, it talks about the terminology, it came around in 1990. If we go back to the history of green chemistry, we will find that this terminology was given by American, that is Environmental Protection Agency. The concept of green chemistry was introduced in around 1990. And the purpose was to motivate the chemical technologies so that you can reduce and prevent the unwanted loss, and you can reduce the risk associated in any kind of production. So, in a very simple manner, if I have to say that in green chemistry, what we want, we try to reduce that waste material. We try to reduce the materials, whatever we use. We try to reduce the energy consumptions. We also try to reduce the risk associated with any process and also the cost. That means it is very important both from the cost point of view as well as from your risk point of view. So if you have to know about how we can do or practice green chemistry, there is a small booklet you can see that is made by American Chemical Society, that there are 12 principles that can be used to make a process greener. And if you see one by one, you will find that first says the prevent of waste, then you have to have the more atom economy, like that you will have 12 principles. Since the time is very short, so I will not go in details. So these are the 12 principles. If we can employ them, then we can make our process greener. So in a simple manner, the green chemistry tries to reduce the waste, it tries to reduce the use of materials, reduce the hazard, and also reduce the risk associated in a process, and also it reduces consumption of energy, and finally it reduces the cost of production. So therefore, green chemistry is very important both in academics as well as in industrial production. So whenever we talk about green, there cannot be something arbitrary. So therefore, there are certain parameters to know about a process, how much green it is. And to know that, we use this green matrix. That means there are different terminology what we use to know about how much a reaction is green based on those parameters. One of the example is that is called the yield. Whenever we think about a chemical process, we try to know what is the yield obtained. That means if theoretically if a reaction goes 100%, we are supposed to get the 100% of the product. But in my process, whether I am getting 100%, 30% or whatever the percent. So based on the percent of yield, we can think about a reaction is how successful. The second thing is that atomic economy. Atomic economy implies that means whenever I do a reaction, then what is the total amount of atoms consumed in the product? You just think about a reaction of addition reaction, where suppose you think about bromination of an alkene. A bromine molecule addition takes place in an alkene, and you end up with a dibromoalkane. That is 100% atom economic process. That means addition reactions are atom economic process because 100% atoms are written. Now think about the elimination reaction where one molecule goes away, and those reactions are considered as less atom economic process. That means whenever we try to develop reactions, we should also think about the atom economy of a reactions, and we should try to make reactions which are much more atom economic. Similarly, there are various other parameters what we use, like the effective mass yield, that is basically the ratio of the product in kilogram divided by hazardous reagent produced during the process in kilogram multiplied by 100. That is what is known as effective mass yield. Another factor what we frequently use, that is known as E factor. E factor is total amount of waste generated in kilogram divided by the total amount of product in kilogram, and the lesser E factor means better method. Okay, so these are the green metrics which is used to know about how green a process is. Okay. Okay, so now I will discuss about a few recent reactions or the methods what we have developed in our lab. So this work was done by our student Nurabul Mandal. He is a BMRF student. So you can see whenever we try to make a method, what I say that to make a reaction green, we need to think about if I can reduce the number of steps, because every step, if the number of steps is more, implies your consumption of solvent is also increasing and your cost of production is also increasing. So if I can do a reaction in a single pot, that means in a single pot, instead of going a multi-step, if I can do it in a single step process, that means I can make my reactions greener. So in our lab, we try to design some reactions which are known as multi-component reactions. The reactions where more than 2 components are added in one pot, and the reactions are designed in such a way that the successive reactions will go under the same reaction conditions. So what we tried to do in this reaction, if you see, we took the concept of that we wanted to develop a very complex molecule but by a very simple phenomena. And what is that concept? The concept is that we wanted to explore that is called organocatalysis. You know that in our biological system, all reactions are catalyzed by enzymes, and enzymes are nothing but mostly organic molecules. The enzymes are proteins. So we are inspired by the biological processes, and therefore we wanted to explore organic molecule as a catalyst. And in this case, what we use a simple molecule. It is a hexafluoroisopropanol, which is an excellent solvent, and it acts as a hydrogen bonding solvent. So we used hexafluoropropanol. Here you can see HFIP to generate this molecule, and along with that, what we use visible light. We use LED light. So in the one-pot process, what we have seen, that means you can make your molecules. Initially, we just using hexafluoroisopropanol at room temperature. Whenever we take this molecule in one pot, we ended up with a molecule where you can see the thiazole moiety is formed. It's not working. The thiazole molecule is there and having amino functionality, hydroxycoumarine, this type of interesting, molecular skeletons, and this type of molecules are known as hybrid molecules because the molecule 1 is having more than one pharmacophore. So then we developed this method that how can you generate this molecule where you are generating two rings. One is the benzene ring and another one is the thiazole systems. That means even at room temperature reactions using light as the source of energy and HFIP as the solvent, you can generate this type of very interesting flat molecules where you have the coumarine moiety, where you have naphthalene moiety and a thiazole moiety. And that is the molecule. By seeing the structure, you can see it is a complex molecule, but the process of preparation is a very simple method. So that means even at room temperature, without having your sophisticated system, you can develop this type of molecules in a very simple way. And this work recently we have published in Journal of Organic Chemistry, published by American Chemical Society. So it is not that after only we have stopped after preparation, we have also shown that this molecule can be further derivatized, and we have done some reactions and we have done their different derivatives. And we have shown that how the reaction works, what is the role of the light and what is the role of our solvent, that is the HFIP. And we have shown that HFIP acts as a hydrogen bonding catalyst, and light basically is used for the 6-pi electrocyclation reaction, and that is how we end up with a very interesting molecule. So after having this reaction, we have developed another interesting reaction. You can see here that we can make this type of trisubstituted thiazole. Because why I am talking about the thiazole? Because if you see the literature, you will find that thiazole molecules are prevalent in various different type of drug molecules. They have a lot of medicinal importance. So we wanted to make all those hybrid molecules where more than one pharmacophore will be there. In this molecule, if you see that the thiazole is linked with another important molecule that is called indole. So we have prepared a system where you can make this type of trisubstituted thiazole linked with the indole by using one-pot method, and simply you can make the product without going through any involvement of any catalytic metals or any hazardous conditions. Like this is a, please go to the later page, just I wanted to see. You can use my pen right maybe. Okay, so to make reactions greener, we also use different strategy. Like here I have shown you one strategy. You can see that we can use lemon juice as one of the organic, as one of the solvent for doing new reactions. So what we did in this reaction, if you see that we took these three different substituents, that is a phenyl glycol, that is the keto aldehyde, you have aminobenzothiazoles, and various different interesting molecules, like you can see that you have hydroxycoumarins or N-methyl hydroxyquinoline. In that case, we can get this type of very interesting tricyclic molecules which are having a lot of significance in the medicinal chemistry. And how we did the reaction, you have simply the reaction you can do at room temperature, and you can use lemon juice freshly extracted, and you can use them as a solvent. So that means to make reactions green, we can use various different strategies. I have shown in the first work, if you remember, that we use the strategy of using light as the source of energy. Here we have shown that you can make reactions greener by using a normal extract from your basically lemon juice that can be used as a solvent cum promoter for doing your organic reactions. That means you can make organic reactions by alternative way than whatever the conventional method we do, because whenever organic reactions comes to our mind, we always think about that means organic solvent has to be used. We always think about some metal catalysis has to be used. It is not necessary always that the reactions, whatever you want to design, that has to be done only using various different type of organic and toxic materials. You can also design reaction in environmental benign manner by using alternative sources, and that is one of the work that we have shown. So since time is limited, so you will find that we have published more than 25 works for making various medicinally important molecules using a simple molecule that is known as phenyl glycol. So it is a ketoaldehyde and having a ketone and an aldehyde functionality in the molecule. So it is a 1,2-dicarbonyl molecule, and we have explored this molecule in multi-component reactions. As I told you, the multi-component reactions are the reaction where more than two components are added at a time. And we have developed various different methods, and we have published this work in various reputed journals, you can see. And in all the cases, these are the one-pot method. One-pot method implies we have used only in the single flask, and we have not isolated every intermediates and purified. So we have added the starting materials, and finally the products were isolated in very good yield. And for doing this type of reactions, by seeing the outcome, it seems a very easy job, because सारा ऐड कर दिया तो कुछ प्रोडक्ट मिल गया, बहुत अच्छा है. But the problem is not that designing reaction, it needs lot of thoughtful thinking, because the molecules that try to behave differently, and you need to bring them, no, you have to come and cooperate. And that is what is the job of the chemist. We need to understand the reactivity, we need to have the understanding about the kinetics, we need to have the understanding about the thermodynamics, and also we need to know at what solvent systems and the proper conditions will be attained, and that is called optimization of the process. So even though if I am showing you one slide that I have developed a method like this, but there are a lot of effort by the students. They do more than 100 reactions to find the optimum condition. So obviously the credit goes to the students, those who are working day and night in our system. And therefore, whatever work I am showing, because of some technical glitches, I have not covered all the things. But mostly if you see, we have done this type of method development where you can generate medicinally important molecules using your one-pot microbiology. Apart from this type of work, we also have, can you go with upper slide? Yes. So you can see that we are also working some amount of in the polymer chemistry, so that can be used in detection of various different elements. We developed a method for making coumarin containing conjugated polymers using simple Suzuki coupling reaction. And this molecule was very interesting because it showed very good fluorescence activity, and even we can also detect mercury and iron detection. It can be done from the water system. So you can use as a chemosensor for detecting mercury and iron using this type of probes. So we also are working novel materials which can be used for environmental remediation. So these are the different areas where we are working right now. Yeah, please go to the conclusion part. Okay, so finally what we are doing at IIT Patna, so we are trying to develop new methods. We use various different new approaches, like some of the techniques, what is right now is the hot topics, that is known as the CS activation. We are working on the CS activation. We are working on development of new methods using green methods in a one-pot methodology that is called multi-component reactions. We are also working on light-mediated reactions, as I told you, that instead of using a normal conventional heating process where it is a highly energy-consuming process, you can design molecules using your visible light. So we have developed some method using sunlight as the direct source of energy. We also have used some method using some organic molecules as a photocatalyst, which can absorb the light and that can transfer energy to the molecules, and it can be used for making your interesting and medicinally important molecules. So these are the various different types of works we are working at IIT Patna. If anybody is interested to collaborate, or if anybody is interested to use our facilities for your information, just I wanted to share, since I am at IIT Patna from the inception time. So we have developed a facility which is known as Sophisticated Analytical Instrument Facility, that is known as SAFE, and it is funded by Department of Science and Technology, Government of India. So we have most of the characterization facilities. So if anybody wants to use those facilities, they can simply write to me or to the coordinator, and you can use our facilities and you can explore your research. Okay. So we always welcome people to visit our places, and if they need any kind of help, definitely they can write to our different faculty members. So finally, please. So these are my students, those who have passed out as a PhD, and they are in different places. One is in the Cardiff University, other is managing and deputy manager in an international company. They are working on agrochemicals. So they are using our method for making your pesticides. Okay, then how you can use your developed method in your industry. So they are using our multi-component strategy for making your pesticides. And similarly, this is right now the PhD students, those who are working in my group. And finally, so this is our department at IIT Patna. And finally, I would like to thank all of you for giving your time. And in future, definitely, once we get more time, so we can share our much more. Thank you.
Thank you, Professor Lokman Chaudhary ji. Your talk was really very good. And now I invite questions from the audience. If any question is there, you may kindly ask, please.
Yes. 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 So as I told you that for doing any reaction, we do not do in a very arbitrary manner, selection. So you need to see the literature that which solvent is an extraordinary solvent. So initially, obviously, we try to do a reaction which is very less expensive, like ethanol or methanol. These are the very less expensive solvent you can buy within 500 rupees, 500 ml you can buy. But HFIP is expensive, no doubt about that. It is 100 gram if you want to buy, it is 5,000 rupees. Okay, so but it has an extraordinary property that has been documented by several research. So it is known as a magical solvent. It basically, because of the having your 6 fluorine atom, CF3, it shows a very good dipole moment. Yes. So the reason as I told you that the reactions, generally if you see the mechanism of the reaction, you will find that these reactions are being catalyzed by acidic condition. You can have two different approaches. Either you can use a protic acid or you can use something like leaves acid or this type of hydrogen bonding activation. The purpose of using hydrogen bonding activation is that since our intention was very simple, that we wanted to make reaction in such a way that once the reaction is done, I wanted to get back that material again and reuse it, so that that should not get consumed in the process, so that it gives you a better, green chemistry parameters. So therefore, since if I do the reaction in HFIP, the materials are soluble in the solvent, and once the product forms, it precipitates out, and you can simply separate them out, and you can reuse the HFIP again for the next cycle. So that gives you the more, much more greener aspect. Yes. Please.
Next.
Yes, in some of the reactions, like you can see that one of the published paper that is in Journal of Organic Chemistry, we have calculated the green matrix and that we have shown. Yes, please. Yes, we have several not this reaction, because if a reaction works at room temperature, why to go for microwave? Because in green chemistry, your purpose is to reduce the energy consumption. So why you will go for microwave if a reaction can be done at room temperature? So we have developed a method, if you see earlier, that we use microwave, and then we used a reaction using seal tube, and then we have come to a condition, no, you can do at room temperature. So that is how the, you can do a process more greener.
So if no questions are there, yes, please.
Yes.
And second one, what are the benefits of lemon juice if you are comparing with the very common solvent?
Yes. Okay. So I will come to your questions one by one. Your first question was about whether we have used a particular wavelength for doing a particular reaction. So we developed a method that we published in European Journal of Organic Chemistry that we have shown because my ongoing project was on light-mediated organic reactions funded by SCRB. So therefore, on that project we are working, and we wanted to do the reaction using your white LED. So initially, because always we think about cost also, because whenever you do research, money is very important thing, right? So we tried to do the reaction with the white LED, and the reaction took around 24 hours. So it was a long reaction time. And then I told my student that can you go and see what happens, you go to the terrace and keep my reaction vessel there and see what happens. And interestingly, we found that in sunlight, the reactions were very excellent, and it was within 6 hours, 100% conversion was there. So there was no byproduct formation, only one single product formed under the sunlight irradiation. Because in sunlight you get a very wide range of spectrum, so therefore the reaction was much more better. But obviously all reactions cannot be done in sunlight. Some reactions where you need to use a photocatalyst, we have also developed some method where we used photocatalyst, that means the molecule itself, starting material itself cannot absorb the light. In those cases we use photocatalyst so that a particular wavelength, the photocatalyst will absorb from the light and then it will transfer energy to the molecule, and that is called photocatalytic process. We have also done some work using that scripts. And what was your last? Lemon juice, yes. Because that was one of the questions from the reviewer, and reviewer asked that why you are using lemon juice, why not you directly use citric acid and water? Okay, and we did this reaction in the presence of citric acid and water, and we found the lemon juice is better than the citric acid and water composition. The reason behind that is that there are many other molecules which are already soluble in your lemon juice which act as a phase transfer catalyst. That means it helps to solubilize the organic molecule in that solution. So therefore, lemon juice showed better result as compared to your citric acid plus water.
So now we should sum up this session. I request Chandrasekhar ji to kindly felicitate the speaker. Thank you. So there were 3 talks in this session. The first talk was by Dr. Manoranjan Kar from IIT Patna. His topic was electrical energy harvesting from nature and smart flexible nano generator. He started with talking on how can electron be defined and what mathematical parameters can be taken help of to define electron and what role does electron play in characterizing materials. He made us know the meaning of nanocomposites, and basically he was emphasizing that in place of using hard piezoelectric pressure materials or pressure sensors, he was probably using polymer based nanocomposites. The second talk was from Ramanand Rai sir from BHU Varanasi, and his talk was on forecast of phase diagram green synthesis of complexes for the detection of chromium 6+ ions. There were some technical glitches in getting his PPT displayed. We are very sorry for that, but in spite of that, he delivered his entire talk extempore, and it was really a good talk, and his basic emphasis was how can phase diagram help us in optimizing the synthesis of green material chemistry. And the last talk was from Mohammad Lokman Chaudhary ji. His topic was reaction with a consens, new frontiers in green synthesis. He talked on different green chemistry matrices and the factors which control chemical reactions for green synthesis. His major emphasis was on controlling the states and chains of reactions, selecting materials and conceptualizing the process parameters for material synthesis in the direction of green synthesis of chemical composites. And it was great to know that he has synthesized 25 medicinal molecules in his laboratory. And I would like to invite the young teachers or the teachers who have recently joined our university system recently in chemistry and physics and other science disciplines, that you should get connected with those people and collaborate with them, take help of their well-developed laboratories to go forward, go ahead with whatever work you are doing. If your work aligns with the work of these great scientists, and even if it is not, then you can take help of them for advancing your work in those directions. So if it is done and even a few teachers from our universities get connected with them, there will be a great contribution of this seminar in that direction. Thank you very much, and I thank all the speakers of this session, and now I hand over the stage to organizers.
Thank you, Santosh sir, and thank you to all resource person for your informative session through PPT and oral. अब हम लोग लंच के लिए चलेंगे. लंच सेशन स्टार्ट हो रहा है. लंच सेशन के बाद हॉल नंबर 1 पे फर्स्ट फ्लोर पे पैरेलल ओरल पोस्टर प्रेजेंटेशन और टेक्निकल सेशन स्टार्ट होगा. तो जिनका निर्धारित जगह पर जो ओरल पोस्टर प्रेजेंटेशन का होगा निर्धारित जगह, वहाँ पे अपना वो पोस्टर प्रेजेंटेशन करेंगे. अब वहीं पे पैरेलल चलेगा, वही पैरेलल हॉल 1 में चलेगा वहीं पे. थैंक यू.
लंच सेशन रूम नंबर 1 ग्राउंड फ्लोर में होगा, वहाँ चल जाएगी. हॉल नंबर 1 खाना, हाँ 1, 2, 3 उसमें होगा, वहाँ लगा हुआ है. थैंक यू.